When we destroy an object, we'd like it to reappear after a while. This goes for both the enemy and also the player as well. In this video, we'll implement a respawning system. The way this will work is we'll create a script called respawner. When an object dies, it will create a respawner and configure the respawner to make the object reappear after a certain delay. Respawner will use a coroutine to, first of all, hide the destroyed object, wait for a certain delay, pick a random location for it to reappear, and then make the object become visible again. The reason why we create this respawner object, rather than having the destroyed object handle it itself, is that when you disable an object in Unity, it stops executing coroutines. This means that we have to have a separate object that will manage it for us. Let's create a new script called respawner. We'll right-click in the assets folder, choose create, C# script, and we'll name it respawner. Let's open it. Our respawner needs to know about two different things: the object that is being respawned, as well as the time between the object being destroyed and the object reappearing. We'll expose these as two different variables on the respawner class. We'll add a public game object called target and a public float called delay. We'll make our start function be a coroutine by changing the return type from void to IEnumerator. The first thing that the respawner should do is to hide the target by setting it to be inactive. We'll do this by saying target.setActive false. Next, we'll wait a certain number of seconds by saying yield return new wait for seconds delay. This will mean that we wait for that amount of time. Next, we need to choose a location for it to reappear. Rather than randomly choosing a point in the world, we'll choose from a collection of predefined respawn positions. This gives us more control over the level as a designer. To do this, we'll create some game objects that have the tag respawn. In the respawn script, we'll get the list of all of these points and then randomly choose one of them. We'll create the respawn points themselves in a moment, but in the meantime, let's write the code that uses them. First of all, we'll get the list of all respawn points. var all respawn points equals GameObject.find GameObjects with tag respawn. This will return an array of all the game objects that have this tag. Next, we'll randomly choose one by saying var selected point equals all respawn points and then index it. The index will be random. We'll say random.range from 0, that is the first object, to all respawn points dot length. This will have the effect of choosing a number from 0 up to but not including the length. So if we had 4 respawn points, it would choose a random number between 0 and 3. Then that number is used to index the all respawn points array, and we get back the selected respawn point. Now that we have this point, we'll move the target to that location. We'll also make the target use the respawn point's rotation as well. This will allow us to define respawn points that aim in a certain direction. We'll say target.transform.position equals selected point.transform position. And target transform rotation equals selected point transform rotation. Finally, we'll re-enable target by saying target.setActive true. And we'll also destroy this respawner by saying destroy game object. Let's now create the respawn points. We'll go back into Unity and we'll create an empty game object. We'll name this respawn point and we'll set its tag to be respawn. This is one of the tags that is predefined by Unity. To make this visible in the editor, we'll change its icon from the default, which is empty, by clicking on the icon at the top left of the inspector and changing its icon to the green pill. This will cause an icon to appear in the middle of the scene view with the object's name. We can now position our respawn point. I'm going to move the respawn point to a point that makes sense to me. About there. I think that looks good. Next, I'll duplicate the respawn point by selecting it and pressing Command D or Control D on a PC, and I'll move the respawn point somewhere else. I'll duplicate it one more time and create a third one and place it somewhere else as well. Next, we'll adjust our damage taking script to make it use the respawner system. Let's open up our damage taking script. First, we'll add a property to the damage taking script that allows it to configure its respawn time. At the very top, we'll go public float respawn delay, and we'll set this to be 2.0. The reason why we're doing this is we'd like different types of damage-taking objects to have a different respawn delay. For example, the player should probably respawn faster than the enemies. Next, in the die function, we'll get rid of the call to destroy. We don't want the game object to be destroyed, which will permanently remove it from the scene. Instead, we want to use the respawn system, which will remove it temporarily and then re-enable it. So we'll remove this line, and instead we'll create a new game object that contains a respawner. We can create new game objects by using the new game object syntax. Var respawner equals new game object. We'll give it a name, respawner and then add our name, gameObject.name. Now, we really don't care about this game object itself. We really only care about the respawner component that needs to be added to it. So rather than having respawner be equal to a game object, we'll actually make this be equal to the result of calling add component respawner. So respawner is now actually a respawner component, and we don't even have to think about things like the transform of it. We can just work directly with the respawner. We'll set the respawner's target to this game object, and we'll set its delay to our respawn delay. At the same time, we'll set our current health to max health. This means that when we respawn, we'll have our health back again. Simply by creating a respawner, we'll kick off the whole sequence of events that involves hiding the object, waiting a few seconds, setting its new location, and then bringing it back. Let's save our script and return to Unity. We'll play the game. We'll aim at our robot and go fire, fire, fire. It vanishes and then reappears at a spawn point. Our enemy now has support for being destroyed and then reappearing.